Welcome students to the NREM 301 lab on stream assessment. We start, as usual, by going to the lab page for this week, which would be week 12. Let's first open the lab instructions and activities document. Our objective this week is to use the stream observations, measurements, and the biological survey to assess stream characteristics and integrity using standard metrics. There are a number of resources provided, including a spreadsheet for making calculations and assessments, data from the biological survey led by Corey Yap of the Concentration Research Training Center, background resources that are a basis of the assessments and ratings that we will apply to our data, and a worksheet to help us assess the biological survey data itself. You should have a copy of your stream survey data sheets, since those will have the data you need for these assessments. Our activities, of course, the first is to enter the data from your data sheets into a spreadsheet provided at the weekly lab page. So let's move back to that site. This is the stream assessments spreadsheet for week 12, so let's open that up. The first worksheet tab has instructions for what we're going to be doing this week. The lab instructions and activities document has more information about each of these, so make sure to read over that before starting to make any calculations. We can start with the basics. That is the date that you took the measurements in the stream, your lab group number, the name of the stream or the tributary that you surveyed, some information about the topography within the riparian zone that you assessed using the visual assessment protocol, the major soil types surrounding the stream, and major land uses, as well as any characteristics that might be important to note as you provide some context or explanations for the stream measurements and assessments that you'll be taking. Most of this information you should already have, but the major soil types, of course, can be found at Web Soil Survey. For stream discharge, only one group per lab section was able to collect this data, so a separate spreadsheet was created so that lab group can enter the data. So let's look at that now. This would be the stream discharge for the lab group that meets on Tuesday and one for Thursday, so make sure you choose the appropriate one. The group that took measurements of stream flow rate and cross-sectional area should enter the data into this spreadsheet. Once they're done, all of the groups can copy that over and put it into the general stream assessment worksheet so they can do the calculations. The first thing you'll want to do on this discharge spreadsheet is to enter the stream name. Then you'll want to include the length of the stream reach over which you measured stream velocity and cross-sectional area. Next, enter the depth of the stream at each distance that you measured it from one side to the other, on the upstream end and then on the downstream end. You can enter either in inches or feet depending upon how you recorded the data. Now, enter the time it took each of the tennis balls to travel from the beginning to the end of the stream reach. If you only did one run or only two balls crossed the stream from one end to the other, that's fine. Just enter as much of the data that you have here for the balls and the runs that you recorded. If the ball didn't cross during one of the runs, you can just enter NA into this cell to indicate that it didn't make it all the way across. Finally, you'll want to give a value for C, a correction factor, to account for the drag on water velocity near the bottom of the stream that's created by the stream bed substrate. Since your group is the one that was wading the stream and making these measurements, see if you can remember whether it was more of a muddy or a rocky bottom. Once this data is entered, again, each group can copy and paste it over, and then we can start performing calculations. Here, we've created a separate spreadsheet to show some of that information just for the purposes of this video. We have data here for a reach of Manoa Stream, which is 20 feet in length. Already included is the raw data for the depth of the stream at different distances across the upstream and downstream ends, and the time it took tennis balls to cross that distance for 3 different runs. The first thing we want to do is to convert the depth from inches into feet, because that's the units we use to estimate the stream flow rate or velocity. Next, we want to estimate the average width of the stream, and so we use the average of the 2 numbers we have for the upstream and downstream width. For the average depth, we'll want to estimate that across all of the depths that we measured, in this case in feet. Next, we calculate the average time it took the balls to flow from the upstream to the downstream end of the reach. We want to take the average of all of the runs of the balls together rather than first trying to estimate the average for each run separately. With these averages, we can now do calculations for cross-sectional area, velocity, and discharge. So cross-sectional area is just the average depth times the average width, because we're assuming in this case the stream cross-sectional area has the general shape of a rectangle. Make sure you have the correction factor from the discharge spreadsheet. In this case, we'll assume it's a rocky bottom stream, so our correction factor is 0.9. The velocity is simply the length of the stream reach divided by the time, the average time it took the balls to cross that length, times the correction factor. Now we have a velocity of 0.11 feet per second. For our discharge rate, that actually equals the volume of water moving through the stream at any one place over the time indicated, in this case per second. So this would equal the cross-sectional area times the flow rate velocity. Or about 0.25 cubic feet per second. For assessment purposes, ratings are given on this worksheet here. They're from a stream assessment protocol developed by the New Zealand National Institute of Water and Atmospheric Research. Slow flow rates tend to allow algae buildup, increase stream temperature, and thus generally reduce the amount of dissolved oxygen needed by sensitive stream organisms. Really fast flow rates limit the diversity of stream habitats and the ability of organisms to maintain their location within the stream. So we want what's considered a moderate flow rate, in our case somewhere between about 0.3 and 2.3 feet per second. Our flow rate is pretty low at 0.1 feet per second, so our rating in this case would be poor. And that's how we do the calculations to assess the stream discharge and flow rate for our stream survey.